Well, welcome everyone to today's ASQ Statistics Division webinar. We have a great presentation today. I have a couple housekeeping things for you. After the webinar, within a couple days, you will receive an email from me. I'm Jenny Helrung, the host, and you will receive an email from me, which will be a record of your RUs, your credits for watching the webinar. I will also give you a link to our Statistics Division webpage, where you'll be able to find the slides for your use under the Resources tab. And there will also be a link to the our YouTube page channel where this webinar will be recorded and posted if you want to view it later. Our speaker today is going to be Fang Zhou, but before he takes over, Michael is going to talk just a little bit about the data science interest group. So Michael, if you want to speak for a minute. And one other thing quick, we're not going to ask questions during the presentation, but you can type them into the chat, and then we will have those answered when we're done with the presentation. We'll read off the questions from the chat, and you can answer them, and I'll moderate the chat if you have any technical questions or anything. So feel free to type any questions that come up in the chat. So Michael, if you want to talk for a second about the interest group.
Absolutely. Hi, Jenna. Thanks for a kind introduction. Hello, everybody. On behalf of ASQ Data Science Interest Group, I would like to welcome you to this seminar. Fang is our member, and we have our group for the last 2-3 years, and we meet bi-weekly and discuss different avenues associated with the data science and how data science and bridge a gap between quality 3 and quality 4. If you're interested to join us, I'm going to paste a link to Data Science Interest Group, and I'll add you to our distribution list. Without further ado, let's pass to Feng.
Thank you, Mike and Jenny. Welcome to the Data Science Interest Group presentation. My name is Fang Zhou. I've been the member, as Mike said, the group for the past couple of years. Really enjoyed the time and learning from everyone. So the goal of this presentation is to share my experience learning analytics in the past 5-6 years, primarily as a student in the Georgia Master of Science in Analytics, and initially as student, and then later now as instructor for the program. All right, so I'll speak about 30-35 minutes or so, and leave plenty of time for questions. So feel free to enter your question in the chat, and we can answer later. All right. So I am a scientist and engineer by training. So like many of you, I have worked in the life science industry in the past 20 years also, and primarily in the R&D function, but I'm spent a lot of time on continuous improvement. So I have in my career, data and computers are common tools for my daily job, and I continue to learn all the new knowledge in data science. So hopefully we can share something with you today. So as a background, more relevant to the data science, I want to share with you my sort of earlier journey, in learning. So starting from my, undergraduate, study, right? Because as an engineer, I learned the basic math, right? The calculus, linear algebra. Over almost 30 years ago, we didn't have personal computer, right? But I had the opportunity to learn Fortran programming for undergraduate research. So that is the earliest exposure to data to computer. In the graduate school, and I studied more protein structure and biochemistry. Although I had exposure to what they call bioinformatics, in terms of analyzing data, but it didn't really do too much for my study. But I did have the opportunity to take some computer science courses, including learning to program in C. It's a very popular programming language. Um, so when I started the industry job first at a biotech company called Invitrogen, I was scientist, developing products, making products, dealing with a lot of data. So the product we had is called protein microarray, um, that has like over 20,000 features per experiment, per slide. And I had to do a lot of analysis for R&D, for manufacturing, production. So I was tired of analyzing data manually, in Excel. So I taught myself how to use Visual Basic for applications, like they call it VBA or Excel macro to automate a lot, the analysis. So it turned out to be very useful, that skill. Um, and at the same time, I was also trained as a Six Sigma black belt, learn a lot, uh, more skills and get on the continuous improvement journey, as well as, got a hooked on statistics, right? Got to use those tools. And I continued the journey essentially at Merck, um, mostly spending my time in improving the business processes, and training and coaching the green belts. And I, also got certified as a master black belt. Um, so after that, I was a consultant at an international firm. We actually help clients improve their process, as well as, you know delivering training, right? Lean Six Sigma continuous improvement, as well as statistical method, right? Quality by design, and I love all the tools. All right, I continue to learn, design experiments. As we know, statistical process control. All those tools are very, very useful. Um, and around 2014, my son was young, and I once stayed home more, and I got a local job leading an R&D department at a biotech company, and where I spent more time, doing research, product development, and designing, experiments and trials, for the products. And about that time, I guess. Last decade, data science became the buzzword. And I was wondering, like, what it was, and what's useful with so many things. And but I never had the time to devote, my effort, to learning. Um, Luckily, around 2017, in Georgia Tech started offer their online Master of Science in Analytics. So it was time for me to change. So I decided to go independent. Starting a part-time independent consulting. At the same time, enrolled in the Geotech's master's program. So I spent about 2 years earning the degree, and after graduation, I became instructor for the program. To date, I'm helping and supporting the students there to learn. And there's also a great way for me to enhance my knowledge, right? This is no better way to learn than to teach. So I'm hoping that I'll give you a little more in today's presentation, my experience. So hopefully that helps you decide, what you want to learn and how you want to learn analytics. All right. So with that, um, it's brief sort of uh, information about the program, and you can go on to the hyperlink here, the website, to get more information. The web has a lot of information there. Um, just disclaimer, because I'm a part-time employee at Geotech, I just want to say that what I'm seeing here does not represent Geotech. I'm here just to share my experience, with you guys. All right. So the program is excellent. As you can see, I think the one of the important factor is the cost. It's very affordable. The entire program costs about $10,000, um, and that is much more affordable than many other equivalent programs offered by top universities. Other universities can be 30, 40, $50,000, whereas this one is $10,000. It's very good value. But you do need to apply and get admitted to be in the program. And there are some uh, basic requirements, prerequisites. All right, you need to have some experience in computer programming, almost any language. You need to have some college level math, right, calculus, linear algebra, and ideally you have some background in statistics. Um, not very high level, not deep level, but some basic level knowledge. Um, the the program has 3 tracks, right? It has little different focus on computational data, so it's a more computational kind of understanding, and then the analytics tools on the different model to solve problems, and then there's a third one is on business problems. So how you use analytics to solve business problems. Um, the uh, program is an interdisciplinary program. Courses are taught by faculty from schools of engineering, computing, and business. So it's a very good foundation for anyone who wants to get into data analytics. Um, the program is 100% online. So everything is online. You can be anywhere in the world and still complete your program. Um, so talking about online learning is fairly new. When I started 2018, this is before pandemic and before working from home. But now I guess everyone is more familiar with working from home or studying from home. Here are the few platforms we use. The first one, Canvas, and that is where you find the lectures or the videos, the homework, and you kind of do your exams. Um, the other one is PS. This is the official channel of communication where I spend most time supporting students. So students can post public messages or send private messages to the instructors. You have questions. Um, you can have discussion with other students. So it's very active and it's very valuable because we as instructors will monitor the channel all the time. And the questions are typically answered within hours, if not within minutes. So it is really important support for the students. And then we also hold live office hours for students. So we use Zoom now, so we can talk with students, give them more instruction and direct answers live. Um, Another platform, Slack, many people use, and we have channels for this program. This is the unofficial community. This is very valuable because you will meet with thousands of students in this program and also alumni and also instructors. So it's a great way to learn from others and just network for your career. So you can learn a lot of things, get to know a lot of people, even after graduation. The last one here is the library. Um, as a student, you have access to online books, articles, a lot of resources. It's all free. So this is a great way to learn more in any area you want, not just analytics. So it's a great program. Um, so now, a common question, right? People always ask, it's like, hey, how much time do I have to spend? Is this, um, you know, I'm always busy. Most students in the program are are, are working professionals, so they are very busy. Um, one thing I want you to know is that all the courses are instructor-led courses. They are not self-paced. Many of the online learning platform, you can actually go there, sign up, and do as much as you want every day, every week, or you can skip a few weeks and then come back. This is not the case. This is really a live, program. So you have to finish each course within the semester. So there are frequent deadlines. You can finish the videos, studying, and submit your homework. The deadlines can be weekly, and you have to do exams within a time frame. So you can't delay. You otherwise will miss the exam or deadlines. Um, Typically, you can expect around 10 to 30 hours per week per course in this program. So it's fairly intense. You got to have spend your time. Um, in general, business classes are simpler. It's probably 10 hours a week, whereas analytics, like the math, statistics courses and the computer courses are heavier. You probably will spend 20, 30, it could be even more per week. So it's pretty demanding for working professionals. Okay. On the other hand, the program itself actually is self-paced. You have up to 6 years to complete uh, all 11 courses. So that is about 1 or 2 courses typically people take per semester. Um, if you're busy, you could even skip a semester, not taking any class. Um, so it's relatively flexible. And many people are able to finish the degree in, like myself, 2 years, 3 years, um, and be successful. Uh, One thing, based on my personal experience as well as observation of other students, is that you really uh, have to consider your other obligations, right? Because you have work, you may have family obligations. So trying to balance the learning with all the other things is a constant challenge for many students. So before considering such a program, just make sure you can afford, in the next few years, that time commitment. All right. So that's about time commitment. The second question, common question people ask is how difficult, right? How hard are the courses? Do I have enough background to learn, coding or the different mathematical models? Um, the answer I think is it depends, right? It depends on your objective. Um, you you also depend on, I guess, your general background, how much you already know. Um, this program is, how much you get depending on how much you put in. Um, the In terms of grades, you need GPA of 2.7 to graduate. That's just about B average. It's actually not that hard. Um, the the programs and the courses are now designed to failed students, right? So the majority of students are able to get A or B in the courses if they are putting enough effort. So I think that's reasonable. Um, and what I think difficult for many students who, like myself, being out of school for 10, 15, 20 years, it can be a bit of adjustment initially. And in the graduate school, you probably don't get much hand holding, except maybe business courses. You are expected to study independently, right? Meaning that you're given some assignment, you're given some general instruction, but you have to figure out some more detail and how to do certain things. Um, this is where the resources, right? The library, online resources you can find, you can just go and search, and also Piazza. the forum where you can ask other students and ask the instructors for help, right? If you get stuck with certain concepts or the homework, and so you don't have a lot of interaction with professors because uh, the program is very large. Like the course I'm teaching, you get over 1,000 students per semester. So you work mostly with other students or get help from the TAs, right? Like myself. Um, so it's very demanding. Um, just to summarize this, right? The overall experience, right, is that if you have a solid background in like math or computer programming or so on thing, um, uh, it's very enjoyable. It's not hard. But if you don't have good background, but you have time, right? You got don't have too much obligation. You can devote much time to catch up, learn on the fly. It's not so bad either. Um, but if you don't have either, it can be challenging because you can catch up a lot of learning, but you don't have enough time because you have work responsibility or family responsibility. It can be pretty tough. So I deal with students every semester who are struggling because of that. Just be aware of those things. Um, so here is just kind of quick summary of my 2 years in the program. So you can see I enrolled during 2018 and 2019. I started spring 2018 by taking the three core requirements. Right, the first one is computing for analytics. It's basically Python programming. Right, uh, I had zero experience with Python, although I had some other prior experience with other program languages. Um, and the second one is analytics modeling, which is also the class I'm teaching today. Um, that introduces a lot of methods. All right, it's kind of survey course. All right, it covers like regression, classification, validation. You can have a design of experiment, time series analysis. A range of methods, but at the introductory level. And that course uses mostly R, which is also a language I didn't have any experience. So um, you can imagine that the first semester or first month, learning a couple things new was pretty rough. But it got better after a few weeks. Um, the third course was business fundamentals, which has nothing to do with the data or math or computer programming. It's actually a business course. It teaches accounting, finance, marketing, business strategy, so on. So that is very helpful in terms of understanding the context of business problems. All right. And then later on, I skipped summer because I had a vacation. Didn't want to have missed a couple of weeks, right? Because it's only like 11, 12 weeks total. In the fall, I had the advanced core requirements. Um, so the first one is data and visual analytics, which is computer course. It's very heavy, very time consuming, easily 30 hours a week. Um, there's no exams, but there are a lot of homework and big project, a team project. And I paired that with the relatively easy course analysis, in business, which is mostly like regression type of analysis. But in any case, I finished the core requirements in the first year and then finished the electives in the second year. Um, so I was able to complete everything in 2 years because I was working part-time. But I think this is probably more challenging for people working full-time. Um, it's doable, but it's more challenging. Um, Another reason I stopped, finish everything in 2 years is that uh, this program allows the alumni to come back and take any course after graduation at the same tuition rate, which is a big bargain. So that also, helped because I could just finish the degree and then I can come back and learn anything in the future as I want. All right. So that is about the program. I know it's a lot of commitment. So if you're not sure you want to devote that much time, to a degree program for a few years, there are non-degree programs. I know Georgia has a few. You can also go to the website, take a look at what they have. Um, I put a few links down here. Um, I'm more familiar with edX because edX has a certificate, basically a micro master um, in analytics, which offers a certificate um, if you complete 3 courses. The courses are identical to the ones offered in the degree program. All right. Uh, if you can just audit, you can just listen to the lecture and learn the knowledge. The difference is when you're paying a fee, you receive the certificate, and also you have access to the instructors like myself. So you can actually ask questions, get support, and that's really helpful and valuable if you are learning things on your own. All right. So that is pretty much the program. Uh, you know, short and short. And I think uh, what I'm going to share with you the next couple slides are what I learned. All right, it's very important um, to understand what analytics is. Um, it's been very confusing in general what analytics is and what kind of skills are useful. What should I learn? Because when I started, I was lost. It was like, what do I want to learn? So in the past few years, after learning the different methods, as well teaching people and also trying to apply in my consulting work, so I simplify analytics, in these 2 dimensions. I just want you to think when you hear about analytics, think about those 2 dimensions. The first one is math. Okay, so like how much math does it involve? Okay, how much do I learn? The second dimension is essentially tools, uh, mostly computer tools. All right, um, at the basic level, uh, there are commercial software applications. Right, you can say Excel. Right, you can use a Minitab for statistical analysis. So those are software tools. They have a graphic user interface. You can just go through the menu, click some options, and you can analyze data. Whereas if you want to go more advanced, learn other tools, you have to learn coding, right? Essentially, what we call command line interface. You have to type your commands or your code, and in order to get the functionality. So that requires you learn Python or similar language. Okay, if you are really good at math, you that you're developing more the new algorithms, I can call you a researcher, all right, in this area. Whereas if you are good at coding, at developing tools, so you're more like developer, right? But what I see for most users, working professionals, I think we're in this corner. We don't really need advanced math, and we don't really need a lot of coding skills to be able to get the most benefit. So when I started, before the program, I think I had a little more skill in coding and math. So I start here and in the middle, and I improved both in terms of mathematics as well as programming after I graduate. Um, for myself, my goal in the future is more about understanding more advanced math and to be able to develop more algorithm or solve more advanced problems. Um, so that's myself. Um, but not everyone uh, has to be like a Six Sigma black belt, right? Just talking about everyone can learn process improvement, but they don't have to be a black belt. So same thing with analytics. Not everyone has to learn advanced math. They can learn a lot of useful tools. Even Excel is very, very powerful. You can learn like Tableau, right, for dashboard development and other things. So what I ask you to think about if you're considering learning data analytics, to use these two dimensions, right? To think about where you are today in terms of math skills, in terms of computer skills, and think about where you want to be for the next step. Right. So I know a lot of things are confusing, but if you think about those two dimensions, things getting easier. Um, so uh, it doesn't answer the question where you want to be. Um, that is the question, in my opinion, is how can analytics make you uh, more productive and more valuable, at your job in your career. All right. So it goes back to the question to say, how does analytics create value? So I learned a lot from working with my clients and helping them um, in their digital transformation as well as building analytics capabilities. And here's my summary. I'm just trying to give you a sort of schematic here. Um, the value start with the business problem. All right. So that's your subject matter expertise to understand the business. But there are also opportunity to translate that business problem into a mathematical problem. Not every problem can be translated into a mathematical problem, but when you are able to translate into a mathematical problem, you now can apply analytics to develop models to create a solution in mathematics. All right. But then that has to be realized, right? It be implemented into a real world, application or solution. And finally, that solution had to be confirmed, right? That is actually solving the original problem. So you can see that is a whole cycle, like just like our, a process improvement, right? The PDCA cycle. But everything here requires data, right? To kind of get data from the process and use the data to create models and solve problems. And you can see that to create value using analytics, it doesn't require just your computer data and mathematical skills. It takes a lot of skills that the quality of professionals already have in terms of understanding business problems, in terms of managing change, developing realistic solutions. So I just want to leave you here to recognize that uh, for most people, uh, we need to find opportunities where the analytics can help our jobs, right? Combining other skills um, to create value. Um, so I'll leave it for now, and I'll summarize the basic takeaway in terms of learning analytics. All right, it's mostly math. It's not really data, and a lot the method already exists for a long time. Currently, the data science so hard because hey, we now have the data software and infrastructure to enable us to apply analytics or the math, and we can take advantage of tools become more efficient and can improve productivity. And if you want to go further, you have to go and study more math and to understand more advanced tools. In terms of applying analytics, I won't be able to talk too much, but it's about creating value, about translating the real problems into something that you can, you know, solve with analytics. Um, and then there are actually a lot of opportunities to use simpler tools. Just like I said, you can use Excel or Power BI or some other tools that they don't involve a lot of math, and you can actually make things faster and better. Um, and my experience and observation is that many organizations are not really ready because a lot of people don't have the basic skills. So it's very challenging. And last thing is the capability is not just in the technical skills, right? Do you know how to program in Python or calling a package or using a tool? But uh, your subject matter expertise, your ability to lead, your ability to manage change, many of the skills we have already are highly valuable. So I don't have time to talk about today, but I'm hoping that we have more chance to discuss. And the data science interest group is a great place to really meet with people and to exchange ideas and learn old skills. So with that, thank you for your attention. I'm happy to take any question. If you want to connect with me later on to have more questions, feel free to connect on LinkedIn. Um, hey Jenny, are there questions?
Yes, there was a question does about the Georgia Tech PhD in analytics. Does it require a thesis?
The the master's program does not require a thesis. It does have a final course that's called a practicum. So you have to do a project. That project can be selected by you if you have employer or a client who has a real world problem. You can formulate a project. Uh, you can call it a thesis, but it's just project. If you don't have a project, the school has a few projects they identify from companies, and they can give it to you so you can try that project.
Great, thanks. I had a question. Is there any particular software that you use a lot?
Uh, well, it depends on the problem, right? And uh, people have different tools they use. Really depends on what people use. If you use general basic data processing, a lot of people like Python to it has a lot of packages you can use to process data. Uh, and some people like R because it has certain packages it's their favorite for statistical analysis. And then there are specialized tools for optimization or for simulations. So there's really no one tool that actually covers everything. Um,
Yes, there's another question. In your opinion, are there key steps that can help improve the chances of successfully applying analytics in a company?
um, Have to be a little more specific about the question. Are you talking about how to apply analytics in their, I guess, operations or research? Is that kind of question?
Yeah, it doesn't say what part of a company, but
Yeah,
maybe somebody that's not using analytics yet and wants to try to take advantage of it.
yeah.
Are there
S-
key things, key metrics? It looks like maybe Michael wants to say something.
yes.
Let me unmute myself. Sorry, and pass the thing. Uh, Another thing is kind of I push a different approach a little bit, kind of without programming. And if you look today, Minitab has a number of data mining tools and data analytics tools, Sigma Excel, and
Right.
there's going to be topics. If you join us for at the World Conference, I'll be presenting about that. But uh, there is democratization process which is happening similar like what we have seen in Six Sigma. At the start, it was statistician, and now there is a more and more democratization where you can solve business problem without understanding all the math and which is currently covered with many programs. And going back to Fang's diagram, I would add a third dimension, which is a business acumen. So you have two dimensions, and third one, which is the most really important, is business acumen, because today around 85% of data science projects fail, and
Right.
they don't bring a value.
Right.
And something what we were seeing with the statistical engineering and everything else until Six Sigma came in a process. So just kind of small addition.
Yeah. That's a good point. I I didn't cover the analytics capabilities companies need to have to realize the potential. This is today. I was mostly talking about as individuals and what kind of things we can learn to improve, and also mostly focus on the technical aspect, uh, not including other skills. I kind of allude at the end, so not just these skills specifically in analytics, but other skills, right? As Mike talked about, just the business skills, the understanding of the organization, the customers, those things are critical in analytics success. Because if we do not define the right problem, it doesn't matter if we get the correct solution here. Um, so um, I will not go into a detail, but I do have a couple backup slides probably relevant here. So let me just see. This is one thing that I discussed during the data science interest group was this organizational capability topic. So I just want to make sure people understand that uh, in order to realize the potential, there are many aspects of the organization that have to be improved. And obviously, there's data, there's data governance, there's general competence, and as well as the infrastructure and many other aspects. So, um, my opinion, going back to the question about a few steps to improve the chance, is I think data literacy is something that every company can improve. Some fundamental, almost think about um, continuous improvement. You train everyone, um, maybe at the yellow belt level, making sure everyone understands the philosophy of continuous improvement and to bring people gradually to a higher level.
There was a question about how beneficial your Lean Six Sigma experience has been in applying the analytics methods versus some of your other educational experiences.
Yeah, my uh, science engineering education as well as Lean Six Sigma experience, they're very helpful. Uh, prepare me for a program at Geotech, definitely. So, um, but you don't have to have uh, necessarily such experience to kind of study analytics. I think there are many opportunities to learn without as much background.
Okay, if I can add, I would say that Lean Six Sigma is a prerequisite for people to have successful projects. And there are different projects. If you're doing a research project, then probably you don't need. So when we look at the organization, you need to have portfolio of similar like when you look at the Lean Six Sigma, you have master black belts, green belts, yellow belts, and white belts. So literacy, digital literacy is almost like a white belt, if I can make analogy. You need a couple of people who are at an extremely high level, like a master black belts, and then you need a lots of green belts and black belts because for master black belts really to be successful, you have that infrastructure below them. Otherwise, you have events rather than whole organizational transformation. And it takes time and a hard work to achieve that transformation. It's a process. Usually there is a hype. People think we're going to get a couple scientists and get some tools, buy some technology, and doesn't work that way. It's a hard work, it's a painful, it takes time and a lot's commitment. So join us for ASQ Data Science Interest Group.
Right, right, and it's absolutely the. I think we will agree that the knowledge and experience outside of the hard skills in analytics, um, they're critical. All right, those skills don't have to come from Lean Six Sigma continuous improvement. It can come from other professional experience. Um, so Lean Six Sigma, project management, or any other methodology, do improve people's kind of effectiveness in applying any tool, any technology in problem solving. I think those are very valuable. And I think also, um, as any project is cross-functional, is that uh, just someone mentioned the collaboration is how we work with other functions, how to understand other stakeholders' needs to actually put together a solution. It's not, you can be a data scientist and you develop a solution and other people are going to use it. So that collaboration, cross-functional collaboration is critical as well. Um, that's a good question. Um,
There was a comment that a lot of companies are getting pushed towards sustainability and a lot of efforts in those areas, and that data science and analytics might be important as some of that data can be spread around the organization. Do you agree with that?
yes, I mean, I see so much potential in all businesses. I work with clients to look at their process improvement and business problems, and I see a lot of potential. I think one bottleneck is I think we talk about is just um, people not aware of the tools available, that they can use to improve what they do. So I would encourage every business to kind of invest in their people, and when people actually have some of the skills, they can improve. Uh, they don't have to be data scientists to improve what they do, um, and definitely there's a lot of potential.
Thanks. I'll put out one last call if anybody has any other questions. We're getting to the end here.
The This
Um,
comment, last question here about off-shelf program. Um, just Yeah, programs like MeTab or any commercial software is very useful, um, and it saves you a lot of time in terms of learning coding. Um, y- I would encourage people to use those tools as much as they can, um, and uh, sometimes can be limiting if you want to do some special problems, but those tools are highly effective for most of the problems. So I, I hope people don't feel that they're pressured to learn the latest, tools, because there are plenty of tools that are useful, as is.
okay, great.
Yeah.
That was very informative. Thanks for the presentation. We will be, again, putting the slides out on the webpage for the STAT division, and we'll be posting the recording on the YouTube channel. So thanks so much, Fang Zhou, for your presentation. And thanks
Thank you for
everyone for
everyone.
joining us today.
Come to our data science interest group. You will learn more, and not from me, from many other people, from their experience. You can ask as many questions as you want. Uh, Thank you, Jenny, for hosting it.
Okay, thank you. Bye for now.
Bye bye.